Simplification using K-maps. How to use the K-maps to simplify the functions. We have this following function given in the standard sum of products as sum of minterms, which are equal to 4, 5, 10, 11, 14, and 15. We reflect this function onto the 4 variable K-map, which is a 16 cell. Okay, this is minterm 4 here, and this is minterm 5 here, and this here is minterm 10, and this here is 11, and this here is 14 and 15. Now we can consider this function as sum of two groups, sum of minterms 4 and 5, which is group A, plus sum of minterms 10, 11, 14, 15, which is group B. This is group A, and this is group B. If we take group A, this is A, sum of minterms 4 and 5. This is minterm 4, and this is minterm 5. You notice that we have something in common between them. We can use the unifying theorem here. We take this part out of the two terms, which is this, and here we have z bar or z. This is equal to 1. So we are left with this term for group A. For group B, which is sum of minterms 10, 11, 14, and 15, we have these two terms together, and these two terms together, there is something common between these two terms, which is wx bar y. We take it out, and we are left with z bar or z. From these two terms, we have x, y, w common between these two terms, which is this. We're left here with z bar or z. Of course, this is equal to 1, and this is equal to 1. So we are left with this. Here also, we have something common, which is w, y. We take it out, w, y, and this is equal to 1. So we are left with w, y. So group B is left with the term w, y. We see that group A ended with the term w bar x, y bar, and group B ended with the term w, y. Each group ended with one term. So the function that we started with, which is equal to the sum of these two groups, is equal to this in its simplest form. We saw that using the K-map is actually based on the unifying theorem, which is A or A bar is always equal to 1. When we group the minterms inside the map that we saw in the first example, we saw that the size of the group is a power of 2. Okay? It can have a size of 1 cell inside one group, or 2 cells, or 4 cells, or 8 cells, and so on. If we group two minterms together, we ended up with eliminating one variable from the group. If we group 4 minterms together, then we eliminate 2 variables from the final term. Grouping 8 squares eliminates 3 variables, and so on. So if we have a group of 2 to the n squares, then the result will eliminate n variables from the final term. So group as many squares as possible inside the same group, because the larger the group is, the fewer the number of literals in the resulting term. Select as few groups as possible to cover all the squares, whether they are minterms or max terms of the function. The fewer the groups, the fewer the number of terms that will result. Okay, let's see how we might group these minterms inside these K-maps. For the first one here, we take one group that includes all the minterms. This is adjacent to this, and this is adjacent to this, and this is adjacent to this. So if we want to get the minimal function of this whole map, then we have only one group that will result in two variable terms. Grouping this one will take these four minterms together and these four minterms together. So we have two groups, this one and this one. In this case, we take this group, which is a power of 2. We have 4 minterms inside it. And then we take this group to cover these two. Notice that it is okay to have these two minterms included in this group and included in this group. And we take these two together. So we have here 3 groups. As we said before, larger groups correspond to product terms of fewer literals. So take larger groups, make larger groups. In the case of 4 variable K-map, one group that includes one cell will lead into a 4 literal term. For example, this one or this one. If we take 2 cells in the group, the result will be 3 literals in the term, like these two. If we take 4 cells, then the result will have 2 literals only. If we have 8 cells, then the result will have only 1 literal in the term. Of course, taking the whole 16 cells, that means the function is equal to 1. When grouping minterms in the K-map, make sure that the group satisfies these conditions. First of all, the group must be rectangular. So this group is not a valid group. This grouping is not valid because it's not rectangular. This grouping is not valid because it's not rectangular. Also, the size of the group must be a power of 2. You cannot have a group of 6 minterms. This is an invalid group. Let's look at this K-map and try to group the minterms in this K-map. First, we take this group, and then we have this group here, and these 4 minterms at the edges can form one group, and this can form one group. These two with these two form one group. But you notice here that these 4 minterms in the green here, they are included in so many groups, and there is no need for this group at all. Okay, let's see how you draw the K-map for the given function. From the De Morgan's theorem, this part of the term is equal to this part. We expand this part, so we have A, B bar, C bar, D bar, which is this, ORed with A, C bar, D bar, which is this. And we have this is left, this is equal to 0, and this is left. Now let's draw the map for this one, but here I want you to notice this. I rearranged the domain, which is A, B, C, D, to have A, B here and C, D here. So this is the area where A is equal to 1, and this is the area where B equals to 1, and this is the area where C equal to 1, and this is where D equals to 1. I have rearranged this, so the minterms here now are ordered in a different way. I'll explain it later. Now take a look at this one. Where is this one on the map? It is where A is equal to 1, B equals to 0, C equals to 0, and D equals to 0. So we have a 1 here. This one covers these 2 cells here. It's where A equals to 1 and C equals to 0 and D equals to 0. This BC here covers these 4 cells, and the last one here covers these 2 cells here. So in these areas, all of them, they are filled with 1s. Now, given that the domain is A, B, C, D, and I have arranged the K-map this way so that we have A, B here and C, D here. Okay, now this one here is inverse to what we usually see. So this cell here has the minterm M0, where A, B, C, and D are all zeros. And here, of course, is M1, where we have A equals to 0, B, C equal to 0, and D equals to 1. And this is where M2 is as a midterm. And this is where M3 becomes. This is M4. M8 is here where A is equal to 1 and the rest of the letters are zeros. This is M6. This is M14. And you can guess what these midterms are. 4, 5, 6, and 7. 8, 9, 10, and 11. 12, 13, 14, and this is M15 here. Okay, and this, given that the domain of the function is A, B, C, D, simplify the function. This is the K-map for the function and give me the result in the standard sum of products. We start grouping. We have, this is the first group. Remember that the group should be as large as possible. And this one here can only be grouped with this one here. This one here can only be grouped with this midterm. And this one here can only be grouped with this midterm. And this one here can only be grouped with this one term. Now there's this one midterm which is left. And the biggest group that it can be included is this. Now what is the term that includes these two midterms? Okay, here A has a value of 0, so it's A bar. And B has changed from 1 to 0, so B is eliminated. It's out. It's not here. Okay, C has a value of 0 in both cells, so it's C bar. And D also has a value of 0 in these two cells, so it's D bar. So the term that represents this group is A bar, C bar, D bar. Notice that B is out because it has changed from 1 to 0 inside the group. One literal is eliminated when we have two midterms in the group. In this group, we have A, 0 here and 0 here, so it stays A bar. C has a value of 1 in both cells, so it's C. D also has a value of 1 here and here. What has changed is B. B is 1 here and 0 here, so it is eliminated using the unifying theorem. If we take this group, then it is A, C bar, D. B has changed, so B is out. And this one is the same, A, C, D bar. B is out. The last group is B bar, B bar, D bar, because A has changed from this on this. C has changed. Here C is 1, but here C is 0. And B has a value of 0 in the group. So this is the term. Now, if we want to simplify the same function, but we want our answer in the product of sum, we make the grouping as this. We make the grouping for the zeros. So we have 4 groups. Okay, this here represents A bar and B bar and C and D. So we have it as a product of sum, A bar or B bar or C or D. Remember, if there was a 1 here, it would be midterm 12. So here we have the max term, which is the complement of midterm 12. And this is the complement of midterm 12 as a max term. For this one, A has a value of A or C or D bar. And B has changed inside this, so it is eliminated. And this group will result in A bar or B bar or C bar or D bar. And this group will result in A or B bar or C bar or D. In 5 variable K-maps, for example, if we have the domain V, W, X, Y, Z, okay, we organize the map as 2 maps. 2 4 variable maps corresponding squares of each map are adjacent, can visualize this as being one 4-variable map on top of the other 4-variable map. Here, inside this map, we have V bar. V is equal to 0. On the other map here, we have V equal to 1. If we take, for example, this minterm, M6, it has adjacent with this, and M14, as well as M4, and it is also adjacent to M22. Notice the count for the minterms here: M0, M1, M2, M3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Here it is minterm 16. Why? Because V here has a value of 1 and all the other letters have a value of 0. So this is M16. You can look here, you see it's M17, M18, 19, 20, 21, 22, 23. Here we have 24, 25, 26, 27, 28, 29, 30, and 31. We have 32 minterms for the 5-variable K-map. Each cell is adjacent to 5 other cells. Let's see how we do the grouping in this 5-variable K-map. K, this is the first group. Remember, the group has to be as big as possible, and we have to include these two and these two in a new group, which is this. So in this function, we have two groups. This is the first group, which includes 16 minterms, and we have the second group, which includes these 8 minterms. Now, this big group will result in Z bar. V changes, so it is eliminated. W also changes inside the group, so it is eliminated. X changes, so it is eliminated. Y also changes. Here it's 1 and here it's 0. And Z is equal to 0 here and here, as well as here and here. So the result is the term Z bar. Notice that this group is 16 cells, so 4 of the letters were eliminated and we are left with 1 letter, which is Z bar. For the second group, we have 8 letters, we have 8 minterms, 8 cells inside the group, so our 2 letters in the remaining term, which are namely X, which has a value of 1 in both sides here, and Y also has a value of 1 in both sides. However, Z has changed. Here Z is equal to 1 and here Z is equal to 0, so it's eliminated. V is changed, of course, it's eliminated. W here is equal to 1 and here is equal to 0, so it is eliminated. Let's see another example for the 5-variable K-map. How do we do the grouping here? This minterm here has only one way to group it, is with this group. And of course, these 4 parts of the group, which we saw before, and these will be included in one group. This group here will result in V bar, because V bar did not change inside the group, W bar, because W is equal to 0, and X is equal to 1.